the power of each term in the denominator is 1. If the power is odd, it means that it has to go up and down. Either way. They can't go both directions. So if you know that this has to go up, you know this has to go up, right? If this has to go up, what does the other side have to do? Down, because it's an odd. This is x. See, this is x equals -4 right here. Which one does that correspond to? +4 or -4? The +4. Because you plug in -4 here to get 0. You plug in -4 here to get 0. So this right here, x equals -4. X equals -4, like that, it corresponds to this one right there. You see that one? And what's the power of that term right there? 1. So it has to go in opposite directions. Boom. So because you know it has to go in opposite directions, you know this one has to go up, so this one has to go down. You know it has to cross there though, right? So you know that this one's going to come up, hit here, but you know it has a horizontal asymptote, right? So what does it have to do after it crosses? It has to go down again. So it's going to go whoop, and then the gravity's going to pull it back down. You could think of asymptotes as having like really strong gravity. They pull things towards them. One question we don't answer in this class until later. Well, there's a point here. What's the interesting point that I'm pointing to? What happens there at that point? It's going up, it's going up, it's going up, it's going up, and then it's a maximum right there. One thing we will learn how to do later in this class, how to find that maximum point without using a calculator. It's pretty cool. Right now, you're not expected to know what that point is because you haven't learned derivatives yet.
After it crosses, it just stays on the top positive side.
Because it doesn't cross anywhere else, so it can't go back down again. There are really cool functions that we'll see later that will actually have a horizontal asymptote. And how many times could it cross? Exactly, it could cross infinitely many times. There's really cool functions that go like this. They go up and down like a sine function, but they get smaller, like sine of x over x. It goes, ooh, it goes down. Any other ones you want to talk about? Any other ones? Big question. I'm going to summarize all the words above with this one question. What does that look like? That's the question we're going to be answering. Flat, flat, flat. What does that look like? Translation, we're going to graph that. But to graph it, we need to come up with all that information you've been learning how to investigate. Generally speaking, what's the first thing you're going to do whenever you see a rational function like this? What's the first thing you're going to do? Factor. Just factor. Do that for me right now. Just factor.
X minus 3.
Yep.
X plus 5.
Nice.
Over x plus 2 and x minus 3.
Who agrees with that? Yay. So first step, factor. That's nice. What's the second thing we should find? Before we cancel, what should we do? Yep.
Domain.
Can you tell me what the domain is?
X
Yep.
such that x does not equal -2 or 3.
Yes. Domain. Now what should we do after we found the domain? Now what can we do?
Cancel.
We can cancel. Exactly. Let's cancel. So we do this, and that cancels out. And what are we left with as our new thing here? So we have equals x plus 5 over x plus 2. What can we now tell that we have one of? What do we have one of? We have a whole. What's the x value of that whole? 3. And how do we find the y value? Plug it in. What do you get? 8 over 5. Nice. Okay, what else can we tell we now have? After we canceled, what do we find now? What do we find now? Vertical asymptote, yep. And that's going to be x equals what, Owen?
Should we find an intercept?
Well, we can do that next. Let's do the vertical asymptote first. There's one vertical asymptote, Owen. Where is it? It's x equals what? Look at the simplified one. Yeah, so it's x equals -2. Exactly. Hey, if we find the vertical asymptote, I love it when I say the answer in the question. The horizontal asymptote. Can someone tell me that? Nasa, can you tell me what the horizontal asymptote is?
Is that what the top can equal?
No, not the, no. Close. What's the degree of the top?
1.
What's the degree of the bottom?
1.
So if they're both 1, what's the leading you look at the leading coefficients now. The leading coefficients are both 1. What's 1 over 1?
1.
So what's the horizontal asymptote?
1.
Y equals 1. Yep. Yeah. Now, the x-intercept is when y is 0, and the y-intercept is when x is 0. So when x is 0 on that, what's y equal? Someone already said it. Yeah? Mm-hmm. And when, this is a little challenging, when y is equal to 0, what does x have to be? What?
Is it -5?
It is. It is, because the numerator has to be 0. So let's look at all the information we have. We have the domain. We know where the hole is. We know where the vertical asymptote is, the horizontal asymptote, and the intercepts. Try this now. Draw me a picture. Use some color in your notes. Use some color in there. There's the proper one right there. Switch those. Whoops.